Hi everybody, welcome to lesson 25. In lesson 25 we're going to talk about the first and second derivative tests for a function that give us a lot of information about the function, specifically about how its graph is going to behave. We have tests for these things, a first derivative test, a second derivative test for extrema, for concavity, for increasing and decreasing, for lots of different things. So in this first video, I think we're going to focus on first derivative tests. And so the first thing we can use a first derivative for is to tell if a function is increasing or decreasing at an individual value or across an interval. Okay. Function is increasing, and this is more of the pre-calc description. An increasing function has a positive slope. As x moves to the right, the y value gets higher, increases. Decreasing functions has a negative slope on the interval. As x moves to the right, the y value goes down. The calculus version of that concept is the analysis of the derivative. Right? So instead of a positive slope, we're talking about a positive first derivative value, or a negative first derivative value is what's going to tell us if a particular function is increasing or decreasing on an interval. And, you know, that's kind of irrelevant when you're looking at a graph. It's almost kind of feels silly, but if we're just looking at a function equation, we don't have a graph and we don't have the ability to create a graph. The analysis of the first derivative is one of the things that would tell us increasing, decreasing, and then would allow us to create a graph. So let's go ahead though and focus on this at first with a graph. And since particle motion is always everybody's favorite, let's go ahead and talk a little bit about this velocity graph. Okay, I'm going to write this again, that this is a velocity graph. Okay. Reminder, if we're talking about a negative velocity or versus a positive velocity, that's going to indicate direction. Okay, so a negative velocity would be moving to the left or down, depending on if we're doing a moving along the x-axis kind of movement or moving along the y-axis kind of movement, since those are the two movements we're focusing on in Calc AB. Positive velocity would be moving to the right or up, the forward movement. So where is my velocity going to be increasing? Velocity, not speed, velocity is increasing anytime my acceleration is positive, or another way to say that is anywhere the derivative of the velocity is positive. And so looking at this graph, I'm going to mark these with some yellow. Here we've got an increasing velocity. Here we've got an increasing velocity. And here we've got an increasing velocity. So how about 5 to 7 and 14 to 16 and it looks like 18 to 19. Notice, irrelevant whether the velocity was positive or negative. When my velocity is increasing, I could show that or know that because in those intervals of velocity increasing is where our slope of our velocity graph or our acceleration is positive. Here, here, and here. Okay. Velocity decreasing right there. And, oh, right here. I was thinking that it, but no, there's two. Okay. So acceleration negative. looks like 2 to 5, union 12 to 14. Constant velocities where my slope is 0. Okay, so a graph is an easy tool. If you see the graph of the function, it's easy to tell where that function is increasing or decreasing. If you don't see the graph of the function and you don't have a tool that's easily accessed to create the graph of the function, we should still be able to tell where the function is increasing and decreasing. We are going to actually look at f prime we're going to look at where f prime of x negative. Okay. Functions decreasing when it has a negative slope or its derivative yields a negative value. Okay, so f prime, 3x squared minus 4x minus 15. Okay. Nothing special here, no fancy schmancy rules, no product rule, quotient rule, chain rule, it's just a straight up power rule derivative, which makes a happy little polynomial, nice little quadratic. And I want to answer that question. Now, I'm really hoping that what I'm about to do now sparks a memory from pre-calc. Because even though you didn't call this a derivative in pre-calc or do anything necessarily with it, the fact that we're looking at a quadratic function and determining where the quadratic function is less than 0 is a pre-calc problem. Okay. So the first tool we do is we either figure out where it's equal to 0 or potentially undefined. Now, this is a quadratic polynomial, so it's not going to be undefined anywhere. X, the domain is negative infinity to infinity. So that's not actually going to be relevant in this problem. But equal to 0, that is going to happen. Now, I'm not going to do a big song and dance about the factoring here. Okay. You have to be able to factor this. Whatever trick you use, whether it's the rainbow method, a box method, a slide and divide, which I hate, however you think about this, the fact is, we need to make a product of negative 15 back here. And we need an outside-inside combination that's going to come out to be negative 4. So thinking about negative 45, which is the product of 3 and negative 15, is kind of a good technique. Looks like a negative 9 and 5 would be the magic combo to get the negative 4 in the middle. So we'll put, how about a negative 3 here, because that'll make the negative 9, and the plus 5. Now, like I said, I don't mean to be ugly, but if your factoring is weak, it's going to show up a lot in this section and it's going to hurt you. You have to be able to factor a basic quadratic. Okay. So that means This function will equal 0 when 3x plus 5 equals 0, or when x equals negative 5/3, or when x minus 3 equals 0, which is x equals 3. We're not answering the question yet. We're still in the part where we're figuring out where it equaled 0. And now we're going to figure out how to use these to answer the question of where this polynomial is less than 0. And this is where we're going to use our number line. We're going to do a number line analysis of our derivative. 3x squared minus 4, actually, let me write it in its factors because it's easier to play with in its factors. So 3x plus 5 times x minus 3, and my boundaries for f prime potentially changing from positive to negative are the places where f prime equaled 0, negative 5/3 and positive 3. If I graphed this, these would be the two places it would cross the x-axis. I can think about a graph for this also. I know enough about how a parabola gets graphed to know that this is a opening up parabola. Okay. So I know my parabola is, something like that. But we can verify if I choose a number in this region of the number line, a number that's smaller than negative 5/3, maybe like a negative 10, something super small, it would make that factor negative, would make that factor negative, would make the whole function positive. This f prime function is positive for x's less than negative 5/3. F prime is negative in this interval. You're like, well, how do you know that? Well, let's pick a number in the interval and check it. An x equals 0 makes this positive, makes that negative, makes the whole thing negative. And then the last one, x is bigger than 3, so maybe x is, I don't know, positive 10, some ridiculously large answer. This would be positive, this would be positive, the whole thing would be positive. So, what just happened? We just figured out whether f prime was positive or negative along different intervals. Whether f prime is positive or negative is what tells us whether f is increasing or decreasing. So from this work, let me undo this. Ooh, big writing. Okay. From this work that I did, I figured out that f of x, actually, let's put it this way. Let's start from what we determined. We needed to figure out where f prime of x was less than 0. F prime of x is less than 0 on the interval from negative 5/3 to 3. Therefore, f of x is decreasing on negative 5/3 to 3. Oh, I can't write. Answering an increasing and decreasing question is going to be a constant set of steps. We're going to look at f prime. We're going to do our best to determine where f prime is positive or negative. And one of the ways to help us figure that out is we will start with thinking about where f prime equals 0 and then identifying the sign changes around that. So when I needed to know this, I thought about the equal to 0 aspect, which took some algebra. But once I figured out where f prime was equal to 0, that's what helped me figure out what f prime was in terms of whether it was positive f prime numbers or negative f prime numbers or positive f prime numbers. This would be a really good place to stop. And 1B is a trig question, so that's going to throw a little bit of a curveball. But you could float over here. No, not yet. And do 3A as an additional practice, increasing and decreasing.